recently named one of New York Times Women in the World, is a contamination control engineer and planetary protection specialist at NASA's Langley Research Center, engineering director. She works in the systems integration and test branch, whose mission is to provide world-class assembly, integration, and testing to support a wide variety of aerospace projects, including fundamental research, engineering development, and flight qualifications throughout all environments. She is a product of Miami-Dade County Public Schools. Yes, Holmes product if you want to know. She earned her bachelor's in mechanical engineering with a minor in mathematics in May 2010 from Florida International University. In December 2012, Denise completed her master's degree in material science and engineering from Virginia Tech. Denise is currently working with the Office of Education, where she leads the Rockets to Race Cars program, a NASA, NASCAR, and Jimmy Johnson's Racing partnership to provide STEM content at racetracks all over the country. Denise's passion for space education and the agency earned her selection as a NASA ambassador and a NASA First 2015 graduate. As part of the outreach efforts, she has been featured in NBC, New York Times, Broadly, MSNBC, Daily Press, Tu Voz, Miami Herald, and Univision. It is my pleasure to introduce to you Denise Aranda.
Thank you. That was a really long bio. Sorry, guys. All right, so as you mentioned, my name is Denise Aranda, and I am a product of Miami-Dade Public Schools. I am so excited to be here, and I'm so proud to be here with you teachers. As you mentioned, I do work at NASA Langley Research Center. We're located in Hampton, Virginia, which is right near Virginia Beach. I know that here in Florida, we have really close ties with Kennedy, but there's actually 10 NASA centers. And of particular interest to me was Langley Research Center, because that's a lot of the research gets done, and I really wanted to do that for my career. So, as you mentioned, I did go to FIU for my undergrad. I had my bachelor's in mechanical engineering, minor in math, and I have a passion for chemistry, so I ended up doing my master's in material science engineering, which you'll find has a really interesting application when it comes to space exploration. Thank you. It's been doing that all morning. Alright, so one of the reasons why I fell in love with NASA, because you guys know we do some really cool stuff exploring the solar system, but what I love the most is this idea that there's this big, vast world out there, and we want to explore it. And to me, it's a very noble thing that NASA does, and the science that we do is very noble, and it's also very cutting edge, and it's very interdisciplinary. And it's one of the reasons why I fell in love so deeply with NASA. So, as you mentioned, my title is Contamination Control Engineering and Planetary Protection Specialist, which is quite the mouthful, okay? It's 2 lines on my business card, it is ridiculous. But the fascinating thing to me is the planetary protection aspect. When you hear planetary protection, you think we're trying to protect Earth from space. And it's actually quite the opposite. We're trying to protect space from Earth. I like to tell kids that we're the guardians of the galaxy. And the way that that manifests itself is, at NASA, we fundamentally want to find signs of life in the universe. Whether that be organics, whether that be on a planetary surface, we just really want to find that. And one of the ways that we do that is by remote sensing, or, like Curiosity, we actually send a rover to make in situ measurements, whether it be wet chemistry, dry chemistry, and probably the most embarrassing thing that can happen to us as an agency is if we get some of this data back and we call a huge press conference and we tell everybody, guys, we found organics, we found life on Mars, and then we find that it's actually Earth microbes that we deposited on the surface. It is a real problem, guys. It is a really complicated science. A single skin cell, a single hair on that rover could throw into question all of our science measurements. On the other aspect is the contamination control engineering, which prior to coming to NASA, I've never heard of, but it's a fascinating science. So, Space is a really dangerous environment, right? We have low pressure, we have radiation, we have atomic oxygen, we've got some temperature fluctuations that are pretty dramatic when you're in orbit, and all of those conditions actually stress materials to the point that they start outgassing. So when these molecules get released, they like to adhere to cold surfaces. That's a problem, right? If they touch something warm, they get energized, they bounce around, it's not a big deal. If they touch something else that's cold, they like to adhere and condense. And a problem for us is that those surfaces tend to be our optics. So I spent 5 years working on this H3 instrument. It's a stratospheric aerosol and gas experiment. What H3 is doing is actually looking at a column of our atmosphere and characterizing the gases and the aerosols that are there. Of interest to contamination control engineers is that while it's orbiting at 17,000 miles an hour and it's seeing really vast temperature changes, all the molecules that outgas condense on the lens that's taking the measurement. So if we don't really take into account not only experimental methods to quantify these gases, but really try to protect it, then we can protect the integrity of the science. Now, another cool thing about H3 and some of the work that I did.
Go click the next page. Oh my God, like the next page. Yeah, we're going.
Okay. So one of the ways that we mitigate that is by using thermal vacuum chambers, and this I had so much fun in. So in that picture at the bottom, that's actually 8 feet in diameter, 15-foot deep thermal vacuum chamber. You could probably fit a small car with you and your friends inside of it. I don't think you'll make it out alive, but you could theoretically. One of the cool things is we have quartz crystal lamps. We can flow liquid nitrogen through that shroud, and we simulate space. We pull a vacuum, we can go to minus 150C, plus 150C, and really just characterize the behavior of spacecrafts when they're in orbit, and that all helps us protect it. Now this is something that's near and dear to my heart. We just launched this a couple of months ago, and talked a little bit about some of the work that we do for deep space, but this is something that we do that's terrestrial science that I think will be of interest. So raise your hand if you've ever been on a flight on an airplane, right? It's pretty much everybody. Okay, keep your hands up if you've been on an international flight, long duration. Wow, a lot of you guys. Okay, did you know that when you did that, you were exposed to radiation? Quite a significant amount, actually. And so what RADx is doing is the radiation dosimeter experiment, and what we're trying to do is quantify exactly how much radiation you got on that flight. So NASA, NIH, FAA, we can't predict accurately how much radiation you're getting. We have a NERIS model, but it underestimates significantly. So what we did is we got some dosimeters, we put them on a balloon project, sent them up to high altitude, took that data, and we're feeding it to the model to have better predictions. This is specifically important for pilots, crew members, women in the first trimester. Knowing how to accurately quantify radiation levels is really important. One of the things that I loved about RADx is NASA as an agency and a lot of STEM jobs have realized that there's a gap. Even with an engineering degree, some of the best engineers, once they get into the workforce, they don't have a lot of whole hands-on experience. So while they have the theory and they understand it, when it comes to applying it to a real-world complex problem, sometimes the gap is not there. So what NASA's trying to do for RADx is they got a lot of young engineers where we're all early to mid-career. We led it. I was the integration and test lead. You can see a thermal vacuum chamber over there that I talked a little bit earlier about. And the idea is that if you give people hands-on experience in science, and they get to build things and test things and iterate them, it makes not only the learning stronger, but it also makes them understand and grasp the concepts better, which is why I love being here talking to you science teachers, because some of the things that you guys do in the classroom with the labs that you're doing is a really powerful way to get students to learn science. How cool is that? I just have to show this picture. So, as I mentioned, we were all pretty young, and we were dead set on taking a selfie in space. And some of the upper management didn't think that we could fly the GoPros, it's not flight critical, and we ended up winning the argument, and we got a little bit of a mass allocation to fly our GoPros and take our selfie in space. We also flew student projects, which is kind of fun, Cubes in Space. I don't know if you guys have heard of that program. but they also flew with us, and the kids really had a lot of fun looking at these pictures. So that's me. I'm going to take you guys on a little bit of time travel. So that's everything up to now. If you have any more questions, I can talk about any one of those topics for like an hour at least. But this was me. It was one of the last pictures that was taken before we moved. I'm from Caracas, Venezuela. We moved when I was 6 years old due to a lot of political reasons. It wasn't a stable country then. It's still not a stable country now. And my family just really wanted a better life for me and my sisters. I'm one of 4 girls. I am a military wife. My husband's on a nuclear submarine. And I have a huge passion for dance. Always dance, still dance. And the reason why I bring up all this personal stuff is because even as I was growing up, I was always fascinated with space and science. I just never thought that I could be an engineer or that that would be an option for me, really. I used to picture an engineer, and that person didn't look like me, didn't talk like me, didn't have my background. And so while the interest and the curiosity was there, it just never seemed like a possibility. So I went to FIU, as I mentioned, and the first 2 years you have to take the same class as everybody else, general ed, and they did have a class on solar system astronomy. And like any human on the planet, I just thought that subject was fascinating, right? I mean, the universe is so vast, trying to understand your role in it, it was just fascinating to me. And luckily, I had an awesome teacher. And his name is Dr. Webb, and he is really quirky, guys. Like, I will never forget him. So he would go to class, and he had a guitar, and he would like play songs about space. And then he personified all the planets, which I thought was fascinating. He talked about all of them, like they had different personalities. And so like Pluto was always the runt of the litter. It was still a planet when I was in college. And he just really changed my mind. I just really fell in love, and I thought to myself, you know what? If I can do this for a living, then I would be set. I am fascinated. So I enrolled, changed my major from dance to mechanical engineering. My family thought I was insane. Honestly, I thought I was too. But I figured, why not? I'll try this for a year, 2 semesters. And if it doesn't work, then fine, I'll just go back to my original plan. We have this physics class that we taught. It was an experimental physics. In college, typically, it's an auditorium kind of like this, and the professor lectures, and then you have 3 tests, and maybe a 1 credit lab, and that's pretty much it. And what FIU did as part of this course was you would do all the pre-work beforehand. So you would listen to the lectures beforehand, you would read things beforehand. When you showed up, it was all hands-on activities. And the fundamental knowledge behind that was, if you discover the answer, you'll learn it better than if you're told the answer. So this was a really interesting lab. We did coefficient of friction, where we had the kids stand up on a whiteboard, and they had to try to slide on both sides. And it was just a really effective, fun way to learn. Engineering school was really hard, really hard. Graduate school was probably the hardest. And even throughout all of that, females are still less than 10%. And I feel really strongly about that, so I'm going to go into girl power here for a second. Even in mechanical engineering, we were less than 10%. For the first 5 years of my career, I was the only female in my group. I was the youngest one by like 15 years, and I was the only Latina. So I was like the only Latina young female engineer. Because one, I feel really proud to go to Virginia and talk about Miami-Dade and talk about Miami and being from here, but also there are girls in your classes that I know felt the same way that I feel, where they have a certain picture of what an engineer is and it doesn't fit the mold, and I feel really strongly. I'm getting emotional, so we're gonna keep going. Anyway, I bring this up because I swear to God, guys, that's an actual picture of me when I graduated with my master's. That is exactly how I felt. It was like the hardest years of my life, but it was so rewarding because now I get to do stuff, and like the Stage 3 project is launching in the fall. You'll be able to see it with the naked eye. You'll be able to see the ice in the sky, and I built that. It's so cool. And then the last thing that I want to point out is a NASA First program. So this is a really unique way. As you can tell, we're having a little bit of fun there, but this is mid-career professionals. There's 10 NASA centers, 40 of us across the agency. 3 people were hand-selected from each NASA center to represent the agency and be the future leaders. And I got selected to be one of the 4 out of Virginia. which I am incredibly impressed with. Thank you. This is really good. This is really good. And what I love about it is the diversity of the group. I know that I feel really strongly about the way it is now, but I'm telling you that things are changing, things are getting better, and I just wanted to put it up there just to kind of showcase that while the generations before us had it a little bit harder, with each subsequent year, it's getting easier and easier for people to pursue their dreams, so I feel really happy about that. Mentioned I was a dancer, I'm still a dancer. I actually teach a girls class, I teach adults and kids, but my girls are ages about 9 to 13 in Virginia. And I only bring this up here to say that I still have a really strong connection with kids and with girls specifically. And even though I'd like to think that I didn't graduate that long ago, the world is definitely different with social media, and I hear it from these kids, so I really commend you guys, because I know that it's really difficult sometimes working in these age groups, but I fundamentally appreciate what you guys are doing. Last thing is the Rockets to Race Car program that he mentioned. So this is kind of interesting. How many of you guys know Jimmy Johnson? Yeah, he's kind of a big deal. So for those of you who don't know, he's a 6-time champion of NASCAR, really huge supporter of education. And one of the things that we did was, he has these ticket packages at the racetracks. And what we found is that there's, kids waiting 45 minutes to get an autograph from Jimmy Johnson. We're talking hundreds of kids. And his PR team said, why don't we use this time to teach kids science while they wait for Jimmy? So they contacted NASA, and sure enough, we hopped on board without hesitation. So we go to racetracks all over the country, and we teach kids about the aerodynamics. There's actually a lot of similarities between the science of a rocket and a race car. We've tried for years to teach kids about lift and drag and the pressure difference, and it's just really hard. A lot of them have never even been on an airplane, but they've all ridden in a car. So the platform that we're using to teach Newton's laws and Bernoulli's equations has just really been a very good platform. Lucky for you guys, you have Daytona and Miami Homestead Speedway really close by. There's a flyer that has all of this information, but the reason why I bring this up is because NASA is offering free PD sessions. So on those 4 topics, it's mostly virtual, where there's NASA education specialists. There's also an opportunity for you guys to come to the racetracks and do these hands-on activities with the kids, and also an opportunity for a classroom to get a field trip to the track and meet Jimmy. So if you're interested about that, feel free to talk to me afterwards. And just last but not least, on behalf of myself as an engineer and all future engineers that are currently sitting in your classrooms, thank you so much for being here. Thank you for letting me be a part of it. And I hope that you guys enjoy the rest of your day. Thank you.